This lesson is our next section on ionic bonding. So we've learnt what the different atoms were last lesson, and let's have a look at where we're going. So now we know that we've got a sodium atom, we've got the different shells, and with our sodium atom, we've got that one little electron that's left out. So his electron configuration is 2, 8, 1. That means he has 11 protons in the middle, 11 electrons on the outside, and he's neutral. But he's not happy. He does not like to have that little one guy out there, mainly because it really wants a full outer shell. So what it does is it wants to kick that poor electron out that's sitting on the outside edge. But what happens to it? It's not abandoned. It can't move unless it's got a place to go. So let's have a look at the chlorine atom. Now, chlorine has an electron configuration of 2, 8, 7. 17 protons, 17 electrons. But its issue is that it's only got 7 in the outside shell. It needs one more electron to go and make it a full shell. So as it says there, can you guess where it gets it from? All right, you're probably right. The chlorine atom accepts the electron from the sodium atom, the sodium one that was moving apart. So let's have a look. There you get that little atom moving across, and these two guys now join together. Now this causes a few little issues though. Because it's losing an electron, okay, it ends up becoming a positive atom. So the sodium is normally neutral, takes away a negative charge. Now it's got only 11 protons, 11 pluses, but it's only got 10 minuses, 10 electrons. So overall it's got a plus charge. Your chlorine had a 17 protons, 17 electrons. Now it's got 18 electrons, one more negative. So that means it has an overall negative charge. And you can just see that happening here. So now that the electrons always, opposites always attract, the electrons stick together. And that actually makes it overall a neutral or a no charge ionic compound. Compound when we've got two or more atoms joined together. And it's ionic because they're sharing their electrons. So now we end up with a sodium ion. The outer electron shell is full. This one's now empty. And we can see that it gets that +1 charge. So if we look at our periodic table again, most of the metals that we can see can lose their electrons. Group 1 metals can gain a 1+ charge. Well, it means they lose electron. Group 2, because they've got 2 electrons in their outer shell, can lose 2 electrons. Therefore, they're up 2 protons. These guys have got 3 electrons in their outer shell, aluminium and boron, so they can have an ion that's got a 3+ charge. Okay, but metals are always end up being positive. Non-metals, which are all these ones over here, can gain electrons, so they can take the electrons off these guys, and that causes them to have a negative charge because they get one more negative. For instance, anyone in this group, like fluorine or chlorine, will end up having a -1 charge. Anyone in this group, because they've got 6 electrons in their outer shell, can have a -2 charge because they can collect 2 more electrons. Nitrogen can accept 3 more electrons, so you can have a 3- charge. When we're talking about our compounds, we always use the metals first, and then we use the non-metals second. Can you see that when you've just got one symbol, so one type of element in that negative ion, we have the start of it, fluorine, start of the atom name, and then the last bit's an "ide," and that tells you that it's an ion. So chlorine becomes chloride, oxygen becomes oxide, fluorine becomes fluoride, bromine becomes bromide. Sometimes these join to make, some of them join together to make a negative compound. So sulfur and oxygen can join together to make sulfate. Hydrogen, carbon, and oxygen can join together to make hydrogen carbonate. And you can see the difference when they've got more than one element making up that negative ion part. We still have this name of the first element, and then we finish it with an 8 instead of an "-ide". And you can see I've drawn them, I've got brackets and I've got the charge on the outside. So that tells everybody that that's a little bundle of elements. Okay, to help us work out what the charges can be, when you come to class, you're going to have a little exercise making some compounds. And I'm going to give you an ion chart, and it just tells you what the charges are of the common ions. Sometimes you can see iron is, instead of ion, a bit confusing, but iron can have a 2+ or a 3+. If you see iron 2, that means it's 2+. If you see a symbol saying iron 3, that means it's 3+. And on the other side, I've got our negative ions as well, including some of our combination ones like carbonate and sulfate. Okay, so just say you want to write the formula of magnesium chloride. First step is to find the magnesium and write it down, and it's got 2 positives. Find the chlorine, it's got 1 negative. And then, so to make it balanced, magnesium has a 2+ charge, so you'll need to have 2 negatives to balance it. So we end up with magnesium plus 2 chloride ions. 2+ plus 2 minuses means it's going to be balanced. And we say that by calling it magnesium chloride, MgCl2. Remember, we put the 2 down the bottom, not up the top, when we're saying that we've got 2 of 1 ion in it. Now it's your turn. In your books, can you write the heading, ionic bonding, and can you have a go at writing the formula for calcium carbonate, aluminium chloride, and aluminium sulfate? Make sure that you use the ionic chart when you're doing that.